Okay, hello students. I want to walk through some of the important concepts of sequences. So last 1.5 week we have learned what is the meaning of arithmetic sequence and what is the meaning of geometric sequence. So I want to make sure we understand what we learned so far. So I want you to please write these notes in your notebook. The first thing is what is a sequence? A sequence is just array of numbers with some order. So it means I'll take one example of sequence. Let me see. Let's 3 and then I'll take 4 and 7 and you know exactly what's happening here is you see I've written some numbers and you will see there what does each number stands for. So that's what I wanted to make sure we get it. I want to make a table out of this and say, okay, if this is the number, then we make a table where the first part, okay, this is the first number, so I call it or step number or the term, the first number, then the second number, the third number, the fourth number, the fifth number, and likewise. So, and the numbers are 3, 4, 7, 11, 13. So sequence is an array of numbers with some order. There is a rule there. The rule here is you can clearly see there's a number that adds up each time. The number that adds each is 4, right? So 3 plus 4 is 7. And then it continues. So this is denoted by, because this is the position, or this is also called what position is the number. So we say, hey, the first position is 3. So this is n stands for what term or number. So we can say when n is 1, and this is, I can name this sequence as, let's say, A. What does it mean is A, in the parentheses we put n. It means, what this means is that A of 1, that means in the first position the number is 3, in the second position the number is 4, in the third position the number is, 3, and then I made a slight mistake here, it should be 3. The number that I put is, there's a mistake here, this number should not be there. So this starts with 3, 7, then 11, plus 4 is 14 and 7, okay? So now you see the first number is 3, the second number is 7, and the third number is 11. That means the number, I'm reading this again and again. What does this A mean? The number at the fourth position is 14, and the number in the fifth position is 70. And all you see is, this is the first, the main thing is this is the start, this is where it begins, and then you work out that, okay, the second position, A2, this A2 is basically 3 plus, and you can see each time you are adding 4. So this is plus 4. So that means you are adding plus 4. And what is A2 basically means, start with A1. So this 3 is A1, so it is the number at the first position plus you are adding 4 to it. That's all it is. Now how did you get 11? 11 is you are adding another 4, it's plus 4. It means 11 is the 7 which you have, that is 7. So the previous number was 7 and you are adding a 4th. And that is, 7 is at second position, so A2 plus 4. And likewise, let's build up this. So I really want you to understand what is the meaning of, the goal is everybody should understand what is the meaning of recursive definition, or we also call it formula. So what is that recursive definition is? Knowing this, we know which term, the numbers at what position, and this is important. Now 14 is you add, what are you adding to 14? How did you get 14? You're adding 4 to 11, so that means it is the it is 11 plus 4. So it is 14 because it is 11 plus 4, that means A of the third. 11 is at the third position, so put A3 and then plus 4. And I have a reason to write all this step. Next is 17. How did you get 17? You add up plus 4. So 17 is 14, so it is 14 plus 4, and 14 is at the fourth position, the A of 4, the previous one, and plus 4. So all this is done just to make you understand that this is where it begins, the very first position, and then so this is when n is 1. Okay, all this is when n is 2 and 3 and then 4 and 5 and so on, like this. That means n is either it is 2 because it is 2 and equal to 2, or it could be bigger than 3. So bigger than 2, it could be 3, 4, 5. So I'm going to put greater than equal to. So this takes care of all this. Instead of saying 2, 3, 4, 5, 6, it takes care. So we can now make a conclusion out of this. And what is it? Is the recursive formula is the very first number, A. So the A1 is 3, so you start with A1 is 3 and any. Now what does this AN means? What does this AN means? The number at any position. This means the number at nth position, right? So it's the number at the nth position. It could be after 5 maybe, could be 6, 7, 8, 9, 10. So the number at any position, right, is, so I'm going to write the number at nth term. So this also is called the nth term. So any term or the number at the nth position is always the one before. Look at the 17 is because of 14 plus. So it's always start with the one before. So if it is 5, this is 5 minus 1, 4. If the number is at fourth place, it means it is 4. So this number, this 14 is at the fourth position. So how did you get it? Because you added 11, so the one before. So that's why this part, look at this. So this is 2, this is 1, so 1 less. This is 3, this is 2, 1 less. So 3 minus 1 is 2. 4 minus 1 is 3. 5 minus 1 is 4. So if I write n, you have to write a, n minus 1, and plus the 4 is the 4 here. And that 4 which you write here. And this is 4. This 4 has a special name. And what is that special name? Every time your position number changes, or every time your n increases by 1, this is the second, this is the third, and the fourth, and the fifth, then you see that there's a rate of change every time you increase by the same. This is called rate of change, and it is also called common difference. So why do we call it? Why is it called common difference? Is if you see that 7 minus 3 is 4. 11 minus 7 is 4. So every time you take a difference between two consecutive numbers, you end up getting 4. So 17 minus 14 is 4. So each time the rate of change is the same. I hope this helps. Just to understand what is this, is to understand what is recursive definition. And this is arithmetic sequence. So this is, why is this arithmetic sequence? Because you can see the sequence, the number each time you're adding the same thing. There is a rate of change. In this sequence, there is a rate of change. You are adding the same thing. It doesn't have to add only, it can be subtracted also. You can have an example of, I can start with 21 and decrease by 3, and say, okay, 21 and 18, and then I can make it 15 and 12. So you can see this time it decreases, you subtract minus this. So the D, the difference rate of change is -3 because you're going down by 3. So that's the recursive. My goal is everyone, and one more thing is not just writing this. So you write this first. So this I already wrote. So you're supposed to write in the box. So this is important. The very first one is 3.
Hello.
Hello. What is that?
It's for Ms. Leah should have sent you guys an email regarding this.
Who's that?
Ms. Leah, Ms. Lopez Gomez,
Okay.
for the, I think it's
Okay, get
the
that.
ELL or something.
So first one is the 3, and then any term is this, and you put a comma there, and then say, okay, this is valid for n greater than equal to 2. So that's 2, 3. So that's what that means. So the same thing, I can wipe this off. So in between, and say, okay, let me take this off. So this is A2 is A1 plus 4. A3 is A2 plus. So this is A4 is A3. This is where I think many students get confused. So that's why I'm making this video, to really understand that every student should write this. That first one is, that's where it begins. So this is where it begins. And then any number is always, is a number in any position is always the number in the previous, the one before. And then you are adding that D, and usually this number has a special name called D, common difference. Oh, here it is, you see? The common difference here. The next thing I wanted to show you is one thing I understand for recursive definition for arithmetic sequence. I want to show for geometric sequence, how do we write? So let me move this camera right here, and this side I'll try to show. Okay, another example. Let's take one simple. I'm taking a very easy example. Start with 3, and then you can clearly see this is the most easiest example, because you can, everybody says that, hey, you can clearly see it starts with 3, okay, and then I'm gonna go this. Mistake. Okay, here. So first place is n. This is n, the step number, also called step number. So what position? Step number is also first position, the second position, the third position, the fourth position, the fifth position. So that's all that means, right? So second and the first. And we say, let's call this as B or Gn. Or you can say, I'm going to call this as Gn. So G means the number and the first. So what this means is your G of 1, the number in the first position is 3. G2 is the number in the second position is 6. The number in the third position is 12. G4 is 24, and so on, right? So the main thing is, okay, we just want to get used to with this. The letters, the uppercase represents the sequence. I can just write another sequence called maybe H, and I can just write maybe 81 and then 27, 9, 3, 1. So this could be another sequence where the name of the sequence is H. So it's just a name. Now why did I pick G is because it's a geometric sequence. How do we know a sequence is geometric sequence? Is because you can see each time you multiply. How do you get 6? What is that? And you can clearly see you multiply 2 and you get 3. 2 times 3 is 6. Again you multiply 2. 2 times 6 is 12. Again you multiply by 2. 2 times 12 is 24, and so on. So there is a kind of a growth factor. This 2 which I'm talking about is, so I want to write that also. This 2 is called growth factor. Okay, and this 2 is also common ratio. Now what is the meaning of common ratio? That's why there's a letter used. 2 is R. Okay, that's called common ratio. And also you can see 6 divided by any term divided by the previous is 2. 12 divided by 6 is 2. 18 divided by, 24 divided by 12 is 2. 48 divided by 24 is 2. And you can see there is a ratio is same. So any term divided by the previous. Now, so this is where it begins. So you have the first number is 3. And then we can build up the later part. So how do we build? So this is 6. How did we get this 6 from? It is because it was 3. It was 3. And what you did was you multiplied by, so you multiply by 2. That means it is 3 times So one more thing I wanted to show is that 3, this 3 is the first one, G1. So I want you to write as this 3 G of the number in the third position, in the first position, and multiply by 2. See? So the goal is, can we get that part? See? That this one is, the next one is G3 is 12. So that means it is 3 times. So you're multiplying the number, the previous number. So how did you get this number? It was 6, and you multiply by 2. And the 6 is in the second position, G of 1 times 2. Then the same thing, how did we get 24? It is because the previous number was 2, and you multiply by 2, that is, and the number 12 is at the third position. In the third position, I made a slight mistake here, this is 2. Okay. So times, I hope I'm making sense to you. And 48 is in the fifth position. And how did we get 48? From the previous number was, so I'm using the word, it is the previous one. So you're multiplying the previous by 2. And this 24 is at what position? It is G4, so G of 4. And likewise, we can write G of 6, G of 7, G of 8. And the question is, can we write a recursive definition? So we can write G of any number. So the number at any position, dot, 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 dot. So here it is. If it is n here, so how do we write the other one? So the number in any position is always, and you can see that you multiply the number one before. So what does this basically mean? The number, the position one before. The number in the position one before. So that was, and then you multiply by the 2. And this is for all n's, not from 2. So start with 2, 3, 4, 5. So start with 2, and then 3, 4, 5, and you put a greater than equal to. So remember, so this is how you write down. So in between, this is what starts. So I'm gonna write G1 here. G1 is where the first number is starts with 3, and then this whole thing is called recursive definition. So in this video, the goal here is, I'm trying to show is, can every student write the recursive definition? If you are given a sequence, can a student write the recursive? So all this means is Gn is Gn minus 1 times 2. And this sequence is geometric sequence. I can take one more sequence, was the one that we did, I think. Hope this helps how to find the recursive definition or recursive formula. And the vocabulary words to be used is the growth factor and the common ratio. I explained that to you. But will the sequence always be arithmetic and geometric sequence? Is this sequence is geometric because there is a common ratio or there is a growth factor? Each time you multiply by 2. And then let me take one example here. Is where a sequence, the one that we did yesterday. So to make sure whether I can see. Okay, now I'm gonna take another one. Okay. Let's take a sequence which is neither arithmetic nor geometric. So the one that we did last time was, remember the number of dots. First there was a dot, 1 dot, and then we had a dot and 2 dots, and then it was 2 dots, and then there was 3 dots, and then there was another one this way, and we have like, see? So when you saw the sequence was, the first one was 1 dot, the second position there were 3 dots, and this one, the third one, there were 6 dots, and the fourth is, you can see there is 10 dots, and if you take the next another one, you add another row with the 5 dots. So what it means is, if this is 1, whatever the n, and this one is a sequence, and this I'll call D, number of, what does D stands for? Number of dots, right? Dn, how many dots are there in the first position? And you can see this one adds plus 2, this one adds plus 3, and they are not the same. 2 is not the same. So this is, it's not arithmetic, and you can see it's not arithmetic. Okay, so this is not arithmetic because the rate of change is not the same. Then also you will see, if I try to check the quotient or common ratio, is it a geometric sequence? Do you multiply the same thing? Now, if you want to know that, say 3 divided by 1 is 3. 6 divided by 3 is 2. 10 divided by 6 will be, I think, 5.5 divided by 3. And this is not the same thing. So they are all different. So this is not geometric sequence. So, but still we can write the recursive formula. Can we write a recursive? That's the point, recursive formula. So what is the recursive formula for this? So it starts with the first one, the number of dots, D of 1 is 1, so that's one thing. And then anywhere, like any terms, the number of dots at any place. Let's say, if I want to know this part, it's always the previous, look at this, it's the 6, this 6, you're adding this plus 4. So it's like, you can see, if this is the first, second step, third step, and the fourth step, so anywhere here, this red dots, they correspond to the step number n is 4. And you're adding to the previous 6, see, the 6 is there, so all you do is, you write dn plus the previous one, so the number of dots in the previous one, previous step, like here, and you're adding what? The n here. So this is the beautiful equation in greater than 2. This is how you're supposed to write recursive definitions. So dn, the number of dots at any position, is always the one, those are previous, and then you're adding the step number. And I hope this helps. And I give an example of arithmetic sequence, geometric sequence, and this one is none of them, but still we can write that. Okay, so there was one more example that we have seen is, in this video I just want to make sure you understood. So the next time we are going to see is nth formula. So what is the definition of how to write nth term or nth formula or explicit formula? So what is that explicit? So the next is lesson number 6. So lesson number 6 is going to be how to write explicit formula for arithmetic sequence and geometric sequence. So explicit formula or nth term. So this recursive formula is only knowing the previous one. Now what is the meaning of explicit formula? I'm going to take the same example as okay. Let me take one example. Just before that, want to make sure that when you talk about for the geometric sequence, make sure it doesn't have to be always a nice number multiplying by 2, the r, or it could be also 1/3, or it could be a fraction. So be careful with that. Now, this lesson number 6 is how to write arithmetic sequence. I'll take the same form example was the one that was given. I think it was 3, and I think I added 3 to the 4 and becomes 7, plus 4 is 11, plus 4 is 15, plus 4 is 19. 4, so yeah, correct, right? So, and then you see this, we can easily make a table out of this, right? 1, 2, 3, 4th, 5th, and so on, right? And you want to know likewise, we want to know what is the beginning. Can we from the beginning, let's say, if this is the first one and this is A of n, and this is n. N is the step number or the position. So is there another way to write down beside recursive formula? Watch this. You start with A, the first one is 3, and this one, see? So you are adding 1, 3, 2, so you are adding plus 4, 2, 3, 3 plus 4 is 7. So that means to get A2, this is the second position. So A2 is, you are adding 3, so the number start with 3 and you are adding a single 4, right? Make sense? Now, how do you get 11? So 11 is, you're adding plus 4 to 7, but you have the 7 was 4 was added to 3. So that means if I want to write the number in the third position, it starts with 3. So always the mean is the 4. And how many 4s I added here is, and clearly you added 2 4s. So 4 plus 4. So I can write here, you're adding 4. So adding 4, and how many times are you adding? Twice. Can you see that? Plus 4. Now I want to know what is the number in the fourth position. So fourth position, the number is, you're adding here another plus 4, and the number is 15. So I think I wanted to write is, of course, this number is, second number is 7, this is 11, this is 15, and 15 is, how did we get 15? Is you're adding 4, 4, 4, 2, 3. So you start with 3, but you are adding 4. How many times are you adding it? Adding 3 times. And likewise, we can get another one. So 19. This 19 is in the fifth position, but we can think of adding 4 how many times? 4 times, correct? So it is the start with 3 plus this 4 times 3. Sorry, 4 times 4, you are adding 4 times. So 4 is added 4 times. And likewise, we can create a nice formula and say, hey, what about the number at any position is always, the starting one is the 3, which is 3, and then plus, so plus 4 times, so 4 times, and then what this, what I want you to really check this out is, if this is 3, if this is 2 here, this is like a single one, see, times 1. If this is 3, this is times 2, so it is 1 less. If this fourth position, it means this is 1 less. So you are, sorry, this 2 is 1 less to 3. So I want to show this. See, 3, then it is 1 less. If it is 4, it is 3. If it is 5, it is 4. If it is n, then it has n minus 1, and that's it. So that's the important and kind of nth term. What is this called? Explicit formula or n term, and this is valid for n greater than 1 directly. You don't have to say first one is just write n greater than equal to 1, because that's where it starts. We have a beautiful equation. So it's always the first one. So an is always the very first one. And there's a special name for this is, you can write the first one, this means the first one, and plus, the common difference is the red color, this is the different rate of change, which is d times n minus 1. And great, and you're done. That's all it is. So sometimes they use A1, this A1 is the first one, but they always give a special name for it, and that is A1. So sometimes they use lowercase A1, A2, A3, A4 like this. Or sometimes you don't even write this, just a A. So basically it means the very first number. So instead of writing this, it could be also write the number at any position is always the first number, see A1, and plus the common difference D and n minus 1. Yeah. I hope that helps. So either you say A1, that's the first number, or you just write lowercase a1, or sometimes you just write just a A, just a single A. Okay? And so this was done, this is for the arithmetic sequence, And for the geometric sequence, we can take the same example since I already have one right here. Let's write I'll take the same example. We start with 3, then 6, double it. So you already know what's happening here is. So how do we write explicit formula for geometric? So we know this is a geometric sequence. And let's see, this is Gn, okay? So the first one, so G1 is, we know G1 is 3, now the 6. So I'll start with G2. So G1, the very first one is 3. And now G2, so G2, you are multiplying twice, correct? Multiply by 2. So multiplying 3, so this is the first, the 3 is multiplied by 2. Okay? So you are multiplying the first number by 3. The number in the third position, you start with 3, but how many 3s did I multiply now? To get 12, you multiply 2. That means from 3, this 3 to this 12, you're multiplying 2 twice. 1, 2. Because 3 times 2 is 6, 6 times 2 is 12. So if I begin with the 3, how do you end up getting 12? Is because you're multiplying 2 twice. 1, 2. So that's why I say 3, and then you say, okay, 2 times 2 times 2. Okay? So which is 3 times 2 and 2 raised to 2. Watch this. So here there are 2. So beautiful things happening here. Next is G of 4. What is G of 4 means? It's the number in the fourth position. Of course, you already know this. G2 is 6. G3 is 12. G fourth position is 24. How did you get 24 from 3? It means, to get 24 from 12, you multiply 2, right? So that means you want to begin from 3. How many 2's are multiplied with 3 to get to 24? You can say 1, 2, and 3. So that means you begin with 3, the black one. Watch this. The 3 is the main important number. And then you multiply 1, 2, and 3. So it means the 3, how many 2's are multiplied is 2 raised to 3. And finally, I'll do one more, that is 48. So the 48 is G of 5. And then, now 48 is because you multiply 2 to 24 get 40. So you can clearly see 1, 2, 3, 4 2's. So the starts with 3 and you multiply this one by 2, 2, 2, 2. And that is the first number. And then you multiply by the common ratio, that's called a growth factor common ratio, which is 2. And how many 2's is 4? I want you to see, can we now generalize this? Can we write an explicit formula? And that's the goal here. So that means if I write G of n, how do I write? So you start with the black 3, so that's the first one. This is the black 3, so the main thing is the 3. And then, watch the beautiful thing. So this basically is 1. So this is 2 raised to 1. If it is 2, use the color. Blue color. Let me use a blue color. So if this is 2, this is 2 raised to 1. If this is 3, third position, there are 2 of the 2's multiplied. If this is fourth position, there are 3 multiplied. If there is fifth position, you multiply 4. That means it's always 1 less than the position step number. So that means if this is n, you multiply 3 times. So it is a common ratio, the growth factor, twice. But how many times do I multiply? 1 less. So you put n minus 1. And here you say, okay, which n? 1, all the n's, position 3, 4, like this. And you say, okay, not just 1, but also bigger than 1, greater than 1, which is greater than 1. So that's the symbol to be used. And I hope that makes. And this is the beautiful formula, or we could call it explicit formula, or it is also called nth term. So nth term means maybe the fourth term. What is the, so this is how you write it. This is the first term, second term, third term, fourth term, fifth term. That's all we say. This is called nth term. Basically means the number at nth position is the first position, the second position, the third position, the fourth position, the fifth position, and that's how you do it. So my goal was just to show that, do we know what is arithmetic sequence? Do we know what is geometric sequence? Do we know how to write recursive formula? And then after that I give a more lesson 6 which talks about explicit formula. Do we know how to write the explicit formula? Explicit formula or nth term. And I hope I made sense out of this. Okay, so this I'm making this kind of videos just to help so many of you. Of course, I want you to write these notes in your notebook to really master this skill. And also, if you don't understand, watch it one more time. Okay, but I just like to make these videos so that all really know. Because the next lesson we're supposed to write after this arithmetic sequence is we are going to write application. Why do we learn this? How do we apply this in real life? So those kind of population growth, let's say the population in the year is so much, and like those kind of problems we'll see. So hope this helps. Thank you. And do write, as I said, write, the more the notes you write, the more you understand, and that's it. We'll continue. I will be also making more videos. I'll give you homework problems on lesson 1, 2, 3. 4 is not there, then the 5 and 6, so that you can practice more problems, and I'll make a videos out of this. Okay. Thanks for watching.